In this video, we are going to define the natural domain of a function. So we've already seen the domain defined kind of informally, and naturally, the natural domain is related to that. Questions about the domain can be kind of ambiguous. We've defined the domain to be the valid inputs of a function. But what does that mean? For example, suppose you have the square root function, and you ask, is -1 in the domain? Well, f of -1, or the square root of -1, is the imaginary unit. So this input does give an output, but in a lot of real world situations, we don't want to consider imaginary or complex numbers. Like we saw this some time ago by now when we were looking at quadratic equations. We asked when a thrown ball reached a certain height, and we found that it didn't reach that height. The quadratic equation had solutions, but they were complex. They didn't have any real world meaning. So in most word problems, you don't want to see the imaginary unit. And we'd probably like to say that -1 isn't in the domain of this function, even though in a sense it's a valid input that gives a valid output. Another example, a of r equals pi r squared. And we ask, once again, is -1 in the domain? And once again, it's kind of ambiguous. A of -1 is certainly a perfectly nice number. It's a valid input that gives an output. On the other hand, this equation, a equals pi r squared, probably sounds quite familiar to you. This is probably supposed to be the function that takes the radius of a circle and gives you its area. I mean, it could just be a purely meaningless abstract formula, but it sure doesn't seem that way. And if this is the area function, then suddenly -1 is out of the domain. Not for mathematical reasons, but for common sense practical reasons. You cannot have a negative radius. So this is a kind of ambiguous definition that can give kind of ambiguous answers. And the natural domain is our solution to that ambiguity. So to talk about the natural domain, we need functions of this form. F of x equals a mathematical expression. Something like, if we remember when I first introduced functions, I talked about a function that takes people and assigns them to their oldest sister. That doesn't have a natural domain. We're looking at mathematical expressions here. And the natural domain is all of the real numbers x such that f of x is also a real number. So going back to those examples on the previous page, if we've got f of x equals the square root of x, -1 is not in the natural domain. Because our output, f of -1, is the imaginary unit I. It is not a real number. A of r equals pi r squared. -1 is in the natural domain. It's a real number. You stick it into this function, you get a real number back again. The fact that this doesn't make any sense from a real world point of view, the fact that you can't have a negative radius, doesn't affect the natural domain. The natural domain is a purely mathematical definition that doesn't consider real world considerations.